Hello everybody, this is the notes for geometry. This is section 5.3. What we've been talking about so far for chapter 5 is just different types of things that happen inside of triangles and different properties. In the first section we talked about mid-segments. That was the one segment that connected two midpoints together. It had a property of half the length of the third side, and it was also parallel to the third side. In section 2 we talked about perpendicular bisectors, and any point on a perpendicular bisector, it's equidistant from those endpoints. And now in this section, like it says here, we're talking about angle bisectors. So again, an angle bisector is, well, let's look at the definition here. An angle bisector, it's a line, ray, segment, or plane that divides an angle into two congruent adjacent angles. All right. I want you to get these notes down, so go ahead and hit pause. You can copy down all the words if you want. At a minimum, you need this part here with the picture. Same thing on the bottom. You need this part here as long as you put the picture here. Otherwise, you need to have the words down to describe these properties. So go ahead and hit pause. Okay. So, what these properties are saying can be described right here. What we're looking at in this picture is an angle. We got angle ABC. That's this angle that I'm moving around. Okay, we have this ray BD. That's this ray here. And it is an angle bisector. You are given these little angle markers here. And so, we have two congruent adjacent angles. That means ray BD is an angle bisector of angle ABC. Now, what I've done here is from point D, I went perpendicular to side BA, and I went perpendicular to side BC. So, what we're talking about here is when you go perpendicular from one point to perpendicular to an object, you're measuring the distance, and that's how you measure distance, from one point perpendicular to that object. So this 2.49 right here, that is the distance from D to point E. This 2.49 right here is the distance from D to point F. Now, points E and F are on the sides of the angles. So you notice how when I move that point D anywhere, that distance is staying the same. Okay, and that becomes the property of an angle bisector. This point D, doesn't matter where it is, it's on the angle bisector. The distance is always the same from the two sides of the angle. Okay, and that's what this property is saying. This first one here, as long as you have an angle bisector, so ray AD is an angle bisector, this distance from D to B is the same as from D to C. On the bottom, it's the converse. If we go the other direction, if we know this point D, I'm looking at the picture down here, if you know this point D is the same distance away, so when you're measuring distance, again, you gotta be going perpendicular. So we need these right angles here, and we need these tick marks. When that point is equidistant from the sides of the angle, that forces these two angles to be congruent, making AD an angle bisector. All right, so some different types of questions that you'll see. Can you conclude that ray BD bisects angle ABC? So just looking at the given information, we're going from point D. We are going perpendicular here to that side. We're going perpendicular to this side. But if BD is going to be an angle bisector, we would need to know those two segments, DA and DC, they would have to be congruent. There's no tick marks here. We can't assume it, so they're not congruent. So then this is no. We can't conclude that BD is a bisector of angle ABC. Looking at question number 5, we have equal distances from D to A and D to C, but when you measure distance, you've got to be going perpendicular. We don't have any perpendicular markers here. And so we don't know if we're measuring the distance from point D to those two sides, from A and to C. And so again, the same thing here is no. We got to have both of these. It's got to be perpendicular to that side, and it's got to be the same distance away from the side. We don't have both in question number 5. Looking at question 6, now we do. point D. We got the little tick marks here and here. So point D is equidistant from A and C, and we're going perpendicular to the sides. So can we conclude BD is a bisector in this one? Yes, we got to have both pieces of information. All right, looking at these two examples here, we'll start with the one on the left. So again, given information is important, just like we talked about in this picture. We're given these arc measurements here. So those are equal angles. So we have an angle bisector. Because we have an angle bisector, because we have perpendicular markers here, we know these two have to be equal to each other. Okay, 4x plus 3 equals 8x minus 9. All right, we have an angle bisector, so as long as we're going perpendicular to those sides, those two distances are going to be the same. And then just basic algebra from the setup here. Subtract 4x from both sides, add 9 to both sides, divide by 4. Okay, sometimes, just like in previous sections, pay attention to what the question's asking for. This question, it doesn't say anything, so we'll just stick to solving for x. It might ask what is an angle measurement, or what is a side length. So plug the x value back. Got to pay attention to the question. Number 9, basically the same thing. Again, you're given it's an angle bisector because those two adjacent angles are congruent to each other. We have our perpendicular markers, which forces those two sides to be equal. So the setup here is 6x minus 17 equals 3x plus 7. And I'll leave the algebra to you. All right, that is it for this section. Well, sort of. We got one more thing to talk about and kind of add to this and take it in a little bit of a different direction. But we'll do that in class, so have a good night.